All right, friends, here we go. This is from the 2015 BC International Test, question number 6. And here we go. Let me turn this just a little bit. Okay. The Maclaurin series for a function f is given by x over 3 plus x squared over 4 plus x cubed over 5 plus dot dot dot. Then the generator x to the n over n plus 2 plus dot dot dot. We need to use the ratio test to find the interval of convergence for the Maclaurin series for f. Well, first of all, because this is a Maclaurin series, we know that the center is at 0. And so we're going to start there. The ratio test, when you use the ratio test, you're going to take the limit as n approaches infinity of the absolute value of a sub n plus 1 divided by a sub n. Well, what's the general term? The general term is x to the n divided by n plus 2. So plugging everything in, we get the limit as n approaches infinity. The absolute value of the n plus 1 term, replace all the n's with n plus 1. So you're going to get x to the n plus 1 divided by n plus 1 plus 2. Well, that's really n plus 3. To divide by a of n is the same as to multiply by the reciprocal. So that's going to be n plus 2 over x to the n. That's your setup, and your calculus teacher has already probably told you you're already earning some points already. Now, what we need to do is we need to evaluate this limit expression. Well, what can we do? I see x to the n in the denominator. I see x to the n plus 1 in the numerator. The x to the n and the x to the n are going to cancel, leaving you just x. Now, be careful. The n plus 2 and the n plus 3 are not going to cancel. So what you've got now is the limit as n approaches infinity, the absolute value of x times n plus 2 over n plus 3. It's important to note here that n is approaching infinity. X is a constant. In terms of our limit, the x is not going to change. So I can rewrite this, if we want, as the limit as n approaches infinity, the absolute value of x times the absolute value of n plus 2 over n plus 3. Because x is a constant in terms of this limit, we can take out that absolute value of x. And now we need the limit as n approaches infinity of the absolute value of n plus 2 over n plus 3. And you might be wondering, well, what the heck is this limit? Well, I see that this is n to the first power and n to the first power. The degrees are the same, which means they're going to grow at the same rate. And when that happens, you look at their leading coefficients. The leading coefficients are 1. And so this limit over here is equal to 1, which means that the whole product is equal to the absolute value of x. Now, what we know using the ratio test is that if the absolute value of x is less than 1, then we have convergence. If the absolute value of x is greater than 1, we have divergence. So we know for sure we have convergence on the interval -1 less than x less than 1. Now, x equals 1 is an endpoint. We're not too sure what happens there. And -1 is an endpoint. We're going to have to test both of those. So to do that, we go back to the original series. If x is equal to 1, then your series becomes 1/3 plus 1 squared over 4 is 1/4 plus 1 cubed over 5 plus dot 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 1 over n plus 2. And this is a familiar series. This is a part of the harmonic series. And we know that the harmonic series diverges. So x equals 1 won't be in your, oops, sorry about that. X equals 1 won't be in your interval of convergence. What about x equals -1? Go back to your original function, and you've got -1 over 3, plus -1 squared over 4, that's 1/4, plus -1 cubed, well, that's going to be a -1 over 5, dot, 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 plus -1 to the n over n plus 2, and we keep going. If I look at this series, here's what I notice. It's alternating. The a sub n's, which all have this form 1 over n plus 2, are decreasing. And if I take the limit as n approaches infinity of 1 over n plus 2, I'm going to get 0. I have an alternating series. The terms are decreasing in absolute value, and those terms are approaching 0. All of this together tells me that the series converges by the alternating series test, or the AST. So let's pull it all together. We know we have convergence from -1 to 1. We know we have divergence at x equals 1 and convergence at -1. So our interval is going to be the closed interval, -1, I guess half closed, to +1. And that matches what the College Board has, so yay me! All right, let's go back and look at where points are going to be earned here. You get the first point when you set up this expression, the limit as n approaches infinity, a sub n plus 1 over a sub n. You then get another point when you compute the limit of that ratio. Identifying this is called the interior of the interval, -1 to 1, gets you a point. Consideration of behavior at both endpoints gets you a point. Even if you maybe reach the wrong conclusion, but you consider both endpoints, you get a point. And then finally, the analysis and the interval of convergence, that's this last piece here. And that gets you a total of 5 points. Not too bad. I would say that this is a pretty typical question number 6 for a BC student. So I'd want to make sure that you are fully prepared for excellence on this. All right, let's keep going. All right. In part B, we're told let g be the function given by g of x equals f of -2x. We need to find the first 3 terms. Usually they're going to say find the first 3 non-zero terms and the general term, that's the a sub n, for the Maclaurin series of g. Well, what do they tell us about g? G is our function f evaluated at -2x. So if you've done this before, all we need to do is go to our original series, which is x over 3, so -2x over 3, plus, then it was x squared over 4, so -2x squared over 4, plus x cubed, -2x, the whole thing cubed over 5, plus ... Then it was x to the nth power divided by n plus 2. There you go. You could, if you wanted to, like when I'm looking at their the College Board scoring rubric, they actually list it out and they say first 3 terms. Well, what are the first 3 terms? -2x over 3, -2x, the whole thing squared, what is that? That's going to be 4x squared divided by 4, that's going to be x squared. -2x cubed is going to be -8x cubed over 5. Your general term is -2x to the n over n plus 2. And that does it. 1 point for the first 3 terms, 1 point for the general term. I am convinced, plus ... that if you wrote this expression out right here, that would get you the 2 points as well, and that really is my preference. But they did specifically say find the first 3 terms, find the general term, so you could list it out separately this way, and that's going to get you 2 points. Again, pretty standard question number 6 for a BC student. Now let's take a look at part C. Part C says the first two terms of the Maclaurin series for f are used to approximate f of 0.1. Given that the absolute value of the third derivative is less than or equal to 2 for all values of x in this interval, use the Lagrange error bound to show that this approximation differs from f of 0.1 by at most 1 over 3,000. Whew. Okay. Well, what's going on here? Sorry that my computer keeps zooming in and zooming out. So the Lagrange error bound says this: your error is always going to be less than or equal to the maximum of the absolute value. Now we're using the first, what are we using? The first two terms. So the Lagrange error bound says that the error is going to be less than or equal to the maximum of the third derivative on the interval containing the center and the point that you're approximating. So we're looking for the maximum on this interval 0 to 0.1 divided by 3 factorial times the value that you're estimating to the third power. Yep, that's what the Lagrange error bound says. This is just a form that you need to know. The maximum of the absolute value of the one more derivative over 3 factorial times the value that you're approximating to that same power. Well, let's do this out. What do we know? We know that f triple prime of x, the absolute value, is less than or equal to 2 all the time on this particular interval. So that this must be true, that this is less than or equal to 2 times 3 factorial times 0.1 cubed. Well, let's keep going. 3 factorial is 6. Now, because this is calculator inactive, I'm going to convert 0.1 into 1 over 10, the fraction form. And what do we get? We get 1/3. 1/10 the whole thing cubed is 1 over 1,000. This is 1 over 3,000. If we track everything through, this says that the error that we're trying to calculate is less than or equal to 1 over 3,000, which is exactly what we were trying to determine earlier. They offered 1 point for what they call the form of the error bound, and then 1 point for all of this analysis, for a grand total of 2 points. That's it, my friends. That's all we needed to do with question number 6. I would definitely go back and look over all the parts. This is a really standard question. I've seen a lot of questions like this in the last couple of years, and I want to make sure you're fully prepared. Good luck.